Okay, so welcome to Unit 2 of Polynomial Functions. We're going to be covering lots of stuff during this unit, mostly graphing polynomial functions and trying to find the equation or family of functions for each polynomial function. So first up, it's polynomial functions. As you can see here, we have linear, quadratic, cubic, quartic, and quintic. They're just basic shapes. And let's do it here. That's the quadratic shape. The quartic shape. The linear shape. And cubic shape. Those are our base functions. Graph the following functions. So I have a few notes here that I need to explain before we move on. When you input zeros into the creation of the function, the operational sign switches when inside the bracket. So if we had zeros or x-intercepts of 4 and 5, it would be x minus 4 and x minus 5. There's an example there. So the x-intercepts signs, operational signs, change when inputted into the function or the equation or function that you create using the zeros. So let's read that one more time. When you input zeros into the function, the operational sign switches when inside the bracket. So if it's negative 5, it's going to be positive 5, x plus positive 5. For negative 5, if negative 5 was your 0, you would input it into the function of x plus 5. 1 or 2 extra points need to be graphed and accounted for in a chart. Input x values into the function with the calculator for calculating the y value. So 1 point will need to be accounted for. Will need to be graphed. You input an x value that you don't already have into the function for the y value. Your output or the answer is your y value. You use the point given to calculate k. K is the coefficient or leading coefficient in front of your function. So it's like y equals k, x minus 5, x plus 5. And we use the point given. We can, for the x values, we input it for the x values and your y value. So finally, the steps. Find the equation, subpoint into f of x and solve for k. Graph with zeros and y-intercept. We have our zeros and our y-intercept, our leading term, or k. We have our basic shape. We have our extra point, and then we sketch. So you can use this checklist to make sure that you have everything you need to graph the polynomials that you're graphing. Okay, I have this example already prepped and done. I'm just going to explain as you can copy through. I'll give you a moment to copy it down. Okay, you can pause and write it down. And I'm going to now explain. Find the equation of a cubic function with x-intercepts -3, -1, and 2 that pass through point 0, 12. So as you can see, we have 3 x-intercepts, making it a cubic function. A cubic function will have the shape of this, unless k is negative, in which it will be reversed if k is negative. And we have our y-intercept 0, 12. So within the equation, as you can see, all the signs are now switched. It is now x plus 3 for the 0 of -3. It is now x plus 1 for the x-intercept of -1. It is now -2 for the x-intercept of +2. When you input it into the function, the sign must change when you are given the zeros or x-intercepts. And so we have subpoint into f of x for k. We don't know the value of k yet. Usually there's a value for k for each polynomial function. What we've done here is we've copied down the basic equation for the polynomial, and we inputted 0 for our x and 12 for our y. 12 is here, 0 is there. And then we calculated for k. K, as you can see, the zeros are now gone. We're left with -6k. And we divide 12 by -6 to get the value of k, which is -2. So we have our final equation for the polynomial. F of x equals -2, x plus 3, x plus 1, x minus 2. So we have our x-intercepts labeled, we have our y-intercepts labeled, and we also see it's a cubic function, but it's also negative, so it's going to be going up. It'll be going up and down because it is negative. If it was not negative, it would be going like this. But because we have our -2 here for k, it is now changed shape. We have our extra point here, which is the value of 3, and it's not graphed because the scale is too small. But for 3, our value for y is -48. As you can see, we inputted our x value of 3 into the function, and our value is -48, and that's our extra point. And it's correct because of the way the graph looks. It's just for double checking. Find the equation for a quartic function with zeros -3, order of 2, 1, and 4 that goes through the point 0, 24. So we have f of x equals k. For order of 2, it's going to look like it's going to look like a quadratic function within the quartic function. It's going to bounce off the axis, looking like a quadratic portion of the function at -3, the 0. And as you can see, the operational sign changes when you input it into the brackets. And now that we have that, now we're going to use 0.24 to find k. Now we have our full equation for the polynomial, the quartic function, with zeros -3, order of 2, 1, and 4. And we used the point that was given, which is the y-intercept, to find k. We just solved for k. And now let's graph. We're going to graph the y-intercepts. We're going to graph the zeros. As you can see, we have the quartic function is now graphed. Let's find an extra point. Let's do 2. As you can see, I should have graphed it a bit lower, and for this part of the graph should be lower, and that's why we do the extra point, just to check for the accuracy of the graph. Determine the equation in simplified standard form for the cubic function with zeros 1 plus and -1 plus and minus √3 and -4 that passes through point 315, so we're not given the y-intercept. So this one is going to be a bit harder, and we're going to have to convert this. Oh my god. We're going to have to convert this into standard form. Get rid of the brackets. And instead of expanding out, which would take a lot, we're going to move x minus 1 down. We're going to square it. And we're going to remove the radical sign and just do minus 3. I'm just wondering if I need another page or not. And we're going to expand this out, and then we're going to use our point to find the value of k. So there's our cubic function, and let's see, our point is 3 and 5, so x is 3 and y is 15. So there you go, you have the official equation for the polynomial. And we're gonna have to graph it with an extra point. One minus the root of 3 is around negative 0.7. And 1 plus root 3 is around 2.7. So I have them already labeled here. There are, oh god, they are x-intercepts. It's a positive cubic function. And it will look like this. So, for these types of questions, you have to follow this. You have to convert this into standard form. I've showed you how. Maybe just take another look and see the steps. Once you get to this point, all you need to do is do x minus 1, 2, and minus 3. So you get rid of this radical sign and it's minus just the number under the square root. And then you expand, and then you have it in simplified standard form, which is what the question asks for. These are very hard to work with, and we're going to do another example towards the end. Give you a moment to write everything down. Okay, so we're gonna do function to graph and graph to function. So as you can see here in the zeros, zeros is -3, order of 2. So it's going to look like a quadratic function. In fact, it is a quadratic function, and we don't have k, but there's k at each beginning. We're just going to practice. So -3, it'll look like this. So zeros. That's what it would look like. So we have -4, +1, and +3. -4 is order of 2, so it's going to look like a portion of it will bounce off the axis, similar looking like to a quadratic function. But it's a quartic function. Quartic function bouncing off the x-axis in a quadratic shape at -4, the 0, -4, and will pass through 1 and 3, making a W shape, or a normal quartic function shape. Order of 2 means it bounces off the x-axis in a quadratic shape, just like shown here. It's a simple quadratic shape shifted 3 spaces to the left. For here, it's a quartic function, so it's going to look like a W. There you go, and there's your shape. Actually, I might. And there's your quartic shape. So here we have another quartic function that passes through -6, forming a quadratic function shape off of -1, and then forms the shape after passing through 4. So we're zeros, -6, 1, and 4. Those are our zeros, and we have order of 2, meaning a quadratic shape will form. So again, it's going to be like a W, since it's a quartic. So here is our quartic shape. It passes through -6, and then it, because it's order of 2 for -1, it forms a somewhat of a quadratic shape because it bounces off -1. It doesn't pass through, it bounces off the axis because it's order of 2. And then it passes through 4, to make a W quartic shape. So that was function to graph, and now we're on to graph to function. So our f of x would equal k. So I have a quartic function and two numbers in which they form a quadratic shape. A quartic function forms two quadratic shapes at -5 and +2 due to order of 2. So both of them are order of 2. Again, notice how the operational sign changes as zeros when inputted into the function. So instead of, if it's a 0 of -5 order of 2, it's +5 within the brackets. And it's +2 order of 2 for the x-intercept. It's -2 when inputted into the brackets. So here's our answer. As you can see here, we have a quartic function that passes through -4 and forms a cubic shape at +5. Cubic shapes mean order of 3. It passes through -4, the 0 of -4. So when we're switching the operational sign, when inputting it into the function, it's +4. And it's x minus 5, since it's +5, and we switch the operational sign when inputting it into the function. And it's order of 3, or to the power of 3, because it forms a cubic shape here. And then it's a quartic function. See, it still kind of looks like a W. That's the issue with order of 2 or order of 3. It affects how the graph looks. As you can see below, it's also a quartic function forming a cubic shape at -2 and passing through 7. So we have another cubic shape at -2, passing through 7. Remember, we switch the operational sign when inputting into the function. Just to let you know. Hopefully you're used to it by now. And there's your answer. F of x equals x plus 2 to the power of 3, or order of 3, and x minus 7. That's our equation for number 6. Okay, determine an equation in simplified form for the family of cubic functions with zeros 1 plus minus the root of 2 and -1/2 passing through point 3 and 35. So, let's see. So what we're going to do is we're going to take this x minus 1 and we're going to square it when we bring it down. And then we're going to get rid of that radical sign. We're going to do minus 2. It's converted into simplified standard form now. And now we're going to use this point to solve for k. We're going to expand out. And then our point is 3 and 35. As you can see, we expanded it out. We used the point, plugged it in, and we found k, which is 5 over 2. And there's our equation for the cubic function. You have to convert into simplified standard form. So we take what we see, we write it down, we get rid of the brackets, we take x minus 1 because they're the same. We put those into brackets and then we bring it down and square it. And then we get rid of this radical sign, or the square root sign, and we go minus the number under the square root. In this case, it's 2, so minus 2. And then you expand out and you get the simplified standard form of the equation. Instead of looking at something that's really hard to understand or something that you may not quite get, we convert into simplified standard form so we can get the entire cubic function. It's just something that you'll have to practice, and I hope that I explained it well enough for you to understand. Anyways, that's polynomial functions. Thank you very much for watching.